Parallel, intersecting, or the same line. The first assignment in a new unit on algebra. This will definitely be a unit where you're going to want to have your Desmos graphing calculator up here on the right, and I'm going to show you exactly why once you hit Attempt Quiz Now. So dive in, and let's see what we got going on. All right, number one, you'll start to see these patriotic lines. That's right, red, white, and beautiful. In this case, red and blue overlapping over the white background. We have to see, do these lines intersect? Are they parallel, or are they the same line? Well, number one is the easiest thing to see. This blue line hits this red line right here. And so, in fact, they intersect. How many solutions are there for this system is this next question. And what that means is how many times do they cross? Wherever two lines cross is the solution to the system of equations. And that's what we'll learn in a lot of different ways this unit. These lines cross once, so they have one solution. And yes, all of us have the first same problem. Same thing for number two. We're going to go through this together. These two lines don't have those arrows we talked about in our geometry unit, but they are indeed, as we look at them, parallel. Meaning, they will never, ever, ever, ever cross. So none. So before you hit next, I just want to ask you, because I always feel for the programmer here. We have three situations that we need to give review for. We have intersecting lines, we have parallel lines, and then we have the same line. So knowing that one line is red and one line is blue, you can feel that the programmer has different choices. They could just make like one purple line, but who's to say that's not just one line that happens to be purple? Instead, here's what they did for number three. Maybe you're already looking at this. This is a situation where these lines are so close together that if you sort of have an eye that goes lazy like I do sometimes if you stare at something too long, if you stare at this and kind of space out, you'll end up just kind of seeing one purple line. It's crazy. Where in fact, if I zoom in, let's see how far I can zoom in here. If I zoom way in, whoa. If I zoom way in, now you can see very clearly, maybe, that this is a blue line next to a red line with the smallest gap in between. So it's not perfect, but you have to acknowledge it's respectable to prove that these two lines, it's an attempt for the same line. So that's why I'm just going to straight up tell you, yeah, you might be complaining these are technically look parallel because they're set different, but it's the way to represent the same line. And the same line touches an infinite amount of times. Every single point on the line is technically touching the other line. So an infinite amount of solutions. All right, now we can get our Desmos calculator going. So we have two equations that I want you to pull up. So type out the equations you have on number 4 into Desmos. I've got this red one here. And I have this blue one. Create my own patriotic red, white, and beautiful situation. And you'll notice that these lines are parallel. Now, why are they parallel? Well, notice here that we have the same slope in front of our x. This is the y equals mx plus b format of our equation. And if we have the same slope, the same number in front of our x, then our numbers are going to be parallel. Reminder that this number on the end is our y-intercept. So the blue line's touching at positive 2, which is why it's 0, 2. And the red one is touching at 0, 8. If I change this 2 to like a 5, then it would move up to positive 5. If I did minus 5, it would drop all the way down to negative 5. But they're still going to be parallel each time unless I change this number in front of the x. Now all of a sudden, they're going to intersect. And wherever they intersect will be our solution. But for this one, they have the same slope. Switch that back. And so these are, let's zoom back into, always try to have between 10 and negative 10 like that. They are parallel, meaning they never touch, so they have 0 solutions. And because we have the same exact problems here, that's why we can't redo individual ones. But if you miscopy or you went ahead and screwed up and then now you're like rewinding the video or fast forwarding to figure out what you missed, you can always submit the assignment wherever you're at, hit finish, grade. It's going to give you a bad grade, but then whatever, just reattempt after that. Okay. The two lines in the above system, so now we notice our x's are not, the numbers in front aren't the same. And I'll show you right now. If the numbers in front of the x, in this case we have 6, and we have negative 5 over 6. I forgot something in that first equation. I'll go up and fix it. Now, yeah, if the numbers in front of x are different, then they'll always intersect. Always. Assuming at least the equations are simplified. So these intersect. How many? Once. All right. Well, it's the same thing for these two. I'm not even going to type it in because I just said if I have one, and this makes sense, a positive slope is going to be going up and to the right somehow, and the negative slope is going up and to the left, and so they're always going to touch somewhere. They're going to intersect at a point. So 5 and 6 are both intersecting, and they intersect once. Well, now we have number 7. This is going to be a good one to look on Desmos. I've got 8 plus 1/4 x, and I've got 1/4 x plus 8. You might be saying, wait a minute, that's the same exact equation, just mixed up. And I know that addition is commutative, meaning 5 plus 2 is the same as 2 plus 5. So, yeah, these are the same line. Now, how do you tell that? Right now I just see the blue one. Well, if you click on the red line, it shows up, and then the blue one, it shows up, and you'll notice clicking back and forth that that line is in the same exact spot, meaning that's the way that Desmos shows that they're the same line. It's different than our programmer who stuck that red and blue one extremely close together. 7 down, 3 to go. 8 is a good one to use your calculator for because in theory you should do some distributive property and simplifying and then comparing, but nah, let's just look at this visually. So that's what the first one looks like. And those things look very parallel. And to make sure I'm doing my math duty correctly, I'll show you what it looks like when it's expanded. So 3 plus 4x minus 1. This is called the rainbow method to review. You multiply that 4 in front of everything on the inside of the parentheses. So it becomes, let's change that back to blue. Okay. 3 plus 4x minus 4. So it's got 4x in it. And then down here, do the same thing there. We get 4x plus 4 plus 3. So that would simplify to 4x plus 7. This would simplify to 4x. 3 and negative 4 make negative 1. And thus, we have this one equation, 3, 2, 1, closing this. We have one equation that's crossing at positive 7 with a slope of 4, and the other one crossing at negative 1 with a slope of 4. In any case, they're parallel because they have the same number in front of x, the same slope, or the rate of change, or the rise over the run. There's lots of names for slope. And you learned that in middle school, hopefully. All right, Desmos is great because it does situations like this, even if you have an equation that's not solved for y. Even your TI yellow graphing calculator, you'd have to solve for y, but not this one. Nope. Instead, we could plug it in and see. Yes. If we divide this whole thing by 2, it's going to be 2x plus 6 to get rid of the 2. And this is a negative 2. And a negative 2 and a positive 2 will always cross. A negative slope and a positive slope will always touch when you have two lines. Somewhere. All right. This final one, we've got y is 1/3 x plus 2, so a positive slope of 1 over 3 crossing at 2. And then we've got this one to simplify. Negative 3x plus 9y is 18. Oh, it went away. Could it be red, blue, red, blue, red, blue. Yep, it's the same one. If you have followed along, you should see a 100%. This is a great little easy assignment to start the unit after we just had our unit review for geometry. If you messed up and want to redo it, let me show you guys who maybe don't know. So say you screw up on number 1, and you're like, these are parallel. And parallel means they intersect an infinite amount of times. So you get it totally wrong. What you can do is you can scroll down. You could hit this finish attempt button. Submit all and finish. Submit all and finish. It took 23 seconds to get a 0. And then when you click back to the assignment, there you go. Now, when you're a student, they got it. Will save your highest grade. As a teacher, I guess it just erases everything I do. But don't worry, your highest grade always sticks. So if you accidentally redo it after you get the 100, you're still going to get 100. Okay, I'm going to end the video here. Have a great day. I'll see you next time for the next algebra unit. Take care.